So let's first take a look at this one, data. Okay, I would like to import some data that we can use those data to do logistic regression and SVM. Okay, so basically I would like to do some classification problem. Okay, so here is the data I would like to use right here. Okay, we want to take a look at this data. Simply just double click this one, double click. Okay, I'd like to load some data to my Orange to analyze. You can simply click right here, browse documentation, right here. So there are some built-in data. The one I would like to use is heart disease, similar to breast cancer. I'd like to use this one, and I open it. And here we can see that, okay, there is a name, okay, how many rows we have? 303. Instance means we have those data points. 13 features. Some of them are missing, but it's still okay. Then it is a classification problem. The class has two values, so it's a binary classification problem. So here we have 13 features right here, and the target will be marked as the grade. As I mentioned before, when you import all this data, you have better to take a look at these types. For example, the first feature right here is age. As we know, it is numeric data, right? So the type right here is numeric, it is correct. And it is a feature, which is correct as well. The second one is gender. Basically, gender is categorical data, right? Female or male. However, such kind of data cannot be input to SVM. So basically, we will deal with these things later. And some other data, some of them are categorical, some of them are numerical. Then, if you want to take a look at this data in a table way, so you can simply drag data table widget and you connect these things. So data will be transferred to the data table. Double click this one, and you can see that. So theoretically, there should be 303 data. The column with in gray, it is a target, 0 or 1, so it is a binary classification. So I'm about to introduce one very useful widget right here. It is called select column. Because some of the columns are categorical, so I would like to remove them because they cannot be used in some basic algorithm. So I'll remove them. So basically, I attach the data right here, and it says selected data to data, and it is a dotted line, which means nothing has been transferred from the left widget to the right one. So I simply click it. Okay, I would like to transfer all data to the right widget. Okay, so click it, and here I can select the columns I would like to use. Select column interface. Okay, how many columns we have? 13, right? So there should be 13 columns right here, and we have one target value, which is right here, and we have a metadata, which is there's that. So I don't want data with C, which means category, to be transferred from the left to the right. So I can drag it from the right to the left, drag it, or I can simply click it and press this button. Okay, or I can select it and drag it. Okay, so in this widget, I only select numerical data to be passed from the left hand side to the right hand side. So let's take a look at this data after the selection. Only has numeric data. I would like to show you how to do the analysis. So when you want to analyze your data, the very first thing you need to use is evaluate. So you drag the test and score to here. That is the center of your analysis. You need your data, so you connect your data. Okay, mark it as data to data. Okay, you transfer all the data. So the first thing is the data you would like to use. Okay, connect to test and score. Which the next thing you would like to use is to select the model you would like to use. Since it is classification problem, and we have introduced logistic regression right here. We have introduced SVM right here. I dragged 2 SVM. So I have 3 different models. I will tell you why we have 2 SVMs. Then we have to connect those things to the test and score, which means please help me to find the best fit line of logistic regression. Please help me to find the best SVM line. So of course there are several different parameters you can select in SVM. So we double click SVM. And as you can see right here, we have several different parameters can be selected here. As I told you, we have a linear kernel, which means just simply draw a line on the original space, big X, to separate the data. So you can simply select linear right here. So SVM linear, linear, okay, give it a name. Okay. So for the next one, this one, I can use another parameter. As I mentioned before, there are several different kernels invented by different mathematicians. Okay, you can simply just try which one is better. We use this one, RBF, 就是你可以选任何一个 kernel 了。Okay, so by selecting this one, your data will be projected to a high level dimension. And SVM will try to separate the data in the high dimension, not in the original space. Okay, if you select RBF right here. Okay, so we have 3 different models, and you simply just click the test. So here is the answer right here. Okay, how do we do this test? Okay, I would like to explain it again. The left-hand side is called sampling, right? We do cross-validation. The number 10 right here means how many data we have? In total, we have 303 data records, right? So 10 means the cross-validation, number 4, 10 means I divide those 303 data points into 10 different sets. So each one has 30 data points. And I use 9 data sets, which is 270 data points to train our model. For example, to find the optimized Z shape in the logistic regression, to find the optimized line in the linear SVM, to find the optimized shape or surface in the RBF SVM. So we have 90% of data to help us to find the optimized A star, B star, theta star, or W star. 好，我们用分成10份嘛，10份里面有9份啊，去找那个 A 星、B 星、西塔星、W 星那些最好的平面、最好的直线在哪里？好，这是最佳化的问题嘛。And then we use only one part, which is about 30 points, to do the test. Okay. For those 30 data points, okay, we have the ground truth Y. We have the ground truth classification, and we simply input those 30 data points to the 3 different models, which is linear SVM, RBF SVM, and logistic regression. And our Y hat, our model will give us Y hat, which means the prediction value of the class. 好，就是我们那30个点呢，就先把 x 丢进去我们的模型嘛，模型不是出 y hat 吗 ？y hat 就告诉你它比较像1还是比较像0的。好，如果是那个 logistic regression 的话，那如果是 SVM 的话，要跟你说它在线的那一边还是在这一边呢？好，如果是nonlinear SVM，它会说这个平面的上面还是平面的下面呢？啊，这样会 predict 的值，那就是 y hat 嘛。Then we compare y ground truth y and your prediction y hat to see which model has best accuracy. So here's the answer. Okay, we have three different models right here: as linear SVM, RBF SVM, and linear regression. You can simply click this one. CA stands for classification accuracy. Since it's a binary classification problem, so we have only two answers: either 0 or either or 1， 就是因为这是个二元嘛，就是 binary 的 classification 嘛，答案不是1就是0嘛，对不对？所以他们就会计算你总共你算对了多少0，跟总共你预测对了多少1，它的总和百分比。So this number, 68% of the data point can correctly fall into the category, which is 1 or 0， 就是有68% 的点可以掉进去正确的那个 prediction， 所以1就 predict 成1， 0就 predict 成0。好，这是SVM linear， 就是它就会在线的那一边啊。And the other one, which one is much better? 76%, which means if you project your data from original space to a higher dimension and you make a RBF SVM, it has 76% of data can be correctly classified into the correct category. And for logistic regression, if we use this data to do the Z shape, okay, of course that is a Z surface because we have 6 or 7 features, right? And the classification rate is 78%, which is much higher. So basically, different models has different capability to classify this data. In practice, okay, if you have such kind of tool, maybe you can just use the algorithm you have learned and try different parameters of this algorithm and make sure the classification accuracy is high enough. So what else of this test and score? Okay, we simply just close it and we connect one more thing, which is confusion matrix, which is very important. Okay, and you connect it behind the test and score widget. Each model has confusion matrix. So, for example, I simply use the logistic regression to explain it. Since it is a binary classification problem, so we have 2 columns and 2 rows. Rows means the actual, which means y. The actual y should be 0 or 1. The predicted means y hat is the model, is the prediction made by your model on the 0 and 1. So this cell 0, 0, it means in total we have 303 data points to describe the heart disease. 就是那个心脏的资料，从303 OK? Actual 139% has no heart disease, so the y is 0. And our model, which is linear regression, its prediction says, okay, those 139% has no heart disease. That is your prediction. So that is correct answer. Okay, 0, 0. At the right hand side, 94% has indeed they have heart disease. And our model linear regression predict they have heart disease. So the purple part, okay, they specify how many instances are correctly classified into correct category. Okay, on the other hand, the red parts, the left bottom cell, it says my model predict 45% has no heart disease, but actually they have. So they messed up. So the linear regression misclassified them. Right side, 25%. Okay, our model says they had this heart disease, and actually they don't. So that is how you read this confusion matrix. Of course, every problem you can draw the confusion matrix, okay, to see how the classification model does. However, I believe different problems may have different impact, which means because this problem is hard disease prediction 就是这个问题是心脏病的预测嘛。So which misclassification is more severe 就是哪一个误判？因为我们说刚刚红色是两种不同的误判嘛，紫色都是对的嘛。这两种误判哪一个比较严重呢 ？Which one is more severe? I think that one. That means in our model we said you don't have any heart disease, but actually you have. This 45 patient, they misclassified by your model, and your model failed to detect they indeed have heart disease. So that is more severe. 就是这个问题会比较严重。So sometimes if the problem is heart disease prediction, you have to decrease the number of misclassification, especially in this cell. If for this cell, for the right hand side for this cell, actually they don't have, but you say they have heart disease. But it is a medical problem, and you can use another method to re-examine if you really indeed have heart disease. 中文就是说，因为这是一个医疗的问题，所以就算你右上角这个错了，其实好像也还好，就是心惊胆跳，就是说你用某一个方法说你现在有心脏病，没有关系，因为医疗你 always 可以 seek for second opinion， 就是寻求第二个意见，你再去看另外一个医生，然后再做一次检查，或许那时候那个检查方式跟我们现在这个检查方式就不一样，然后你就可以说你其实是没有心脏病，所以右上角那个就是虚惊一场。比较没有在医疗问题上比较没有问题，可是左下角这就很不得了了，因为那根本就是他有病，你有机会去检验他，但是你居然没有检验出来，而且这有时候是右上角重要，有时候是左下角重要，这完全要看你的问题这完全要看你的问题。Okay, so that is the definition of confusion matrix, and we can see that different method, okay, different algorithms, they have different confusion matrix. Okay. However, usually we use classification accuracy to rank different algorithms. There are several other index, which is F1 precision and recall, and then we come back to as you can see. Okay. Usually we draw confusion matrix by using two dimensions, right? One part, okay, make sure is the actual value, okay, which is cat and dog. The prediction classes, okay, which is your prediction, okay. We simply draw how many instances is in each cell, okay. And sometimes we use positive or negative, okay. So when you do such kind of confusion matrix, okay, make sure you take a look at this very special matrix right here. The left hand side we have a cell called true positive, and at its right hand side is true negative. Okay, what is true positive and true negative means? So let's take a look at the true positive. At the top it means true condition, at this left it means predicted condition. So true positive means the actual answer is true, it's positive, it's yes. And your prediction is true, it's positive, it's yes. So that is true positive. So in our previous case, that means you have heart disease, and my prediction is true, you really have heart disease. Okay, that is true positive. The true negative means your target is 0, is no, is -1, and my prediction is 0, is negative, is -1. So that is true negative. So the other two part, false positive or false negative, or referred as type 1 error and type 2 error, which means they are misclassified， 就是这两个是不同种类的错嘛，啊，分别是 for false positive, it means your answer is -1 is 0 is negative, but your prediction is positive is yes or is 1， 就是错编的嘛，就是 false positive 是说对方我们现在的 target 应该是-1啊，或是没有心脏病啊，或者是错的啊。那可是我们 predict 出来的模型居然说它是1是 yes 是正的，好，就是这样，好，所以那边叫 false positive， 那这一边就叫 false negative， 好，这是一模一样的。So basically, these four cells, true positive, false positive, false negative, true negative, these four cells form the confusion matrix. However, there are several other different index which is derived from these four cells. Okay, let's take a look at the right hand side. Did you find this one? Precision. Precision means you have to summation all true positive numbers, okay, and divided it by summation of predicted condition positive. Then the number is precision. The left hand one, the yellow one, there is a cell called recall. Or sensitivity. It means summation all true positive divided by condition positive. Condition positive. 就这两个分，对吧？对，它分子是 true positive 嘛，它就这个格子，绿色这个格子。它的分母是 condition positive。condition positive 写在这里，对不对？写在这个 column， 它指的是 true positive 再加上 false negative 的值，当做这两个分母。所以 recall 是一个分数，它指的是说在这一个 column 里面 ，true positive 占这两个比例，对啊。precision 是这样子嘛，它指的是 true positive，true positive 也是这个，对不对？然后这是 predicted condition positive，predict condition 在这里，你只是好在这里，它指的是说这两格里面绿色占的比例。So for precision, it means how many percentage the true positive, two just true positive plus false positive. Sensitivity or recall means the percentage of true positive to the summation of true positive plus false negative. 好，所以其实这个表格没有什么特别，就是这四个值的各种比值跟加减的组合变化而已。Okay, so sometimes we use this figure, use index to measure how good is your model. Basically, the better your model is, the number of true positive and true negative will be higher, right? So when you calculate a number like recall or precision or even accuracy, it should be higher. But there are several different index, right? So basically, currently, okay, in practice, we use the last index, which is called F1 score, at the right hand side. F1, the F1 score is 2 times precision times recall divided by precision plus recall. It's just a number. The higher precision you have, the higher recall you have, then the higher F1 score you have. And if you want to get higher precision or recall, then you should have higher true positive and lower false negative and lower false positive. And you have higher true positive, lower false positive, lower false negative, and then you have high true negative. 反正这些指标的意思就是要让你那个绿色那两块要越高越好，那红色两块要越低越好，那它的比例要越低越好，就这样子。所以有个综合，so we have a complex index， 就是它这个综合的指标。 那指标最后就是用那个 F1 score 就这样算。啊，它是一个procedure 跟 report 的成绩除以一个加 report 啊，比如说 report 一个在这边，一个在这边。So that is computer metrics. So basically, all those data analyzed tools, they provide all those information in this simple widget. They tell you what is the precision of this algorithm, report this algorithm, and the F1 score. Of course, classification accuracy is very easy, very to understand. But however, if you write your paper, you do your homework review, or do your research, most of the time you use F1 score. Another thing I would like to say is when we use the word tenfold, okay, we divide the original data into 10 parts, and we use 9 parts to train and 1 part to do testing, right? But actually, the process might like this. We preserve the first part to do testing and use the rest of the 9 parts to do training, and that is round 1. And round 2, we preserve the second set for testing. Use the first set and the third to the 10th to do training as the second round. And for the third round, we preserve the third data set for testing. And 1, 2, 4, 5, 6, 7, 8, 9, 10 is 9 data set to do training, and so on and so forth. So for 10-4 testing, 10-4 cross validation, eventually we test all data, right? And we have 10 different runs. OK， 就是说在 10-4 里面呢，虽然我们是把资料分成10份，可是我们也是分成10个 run。第一 run 是拿第一份做测试，其他9份去做 training， 得到最好的 A 星、B 星、W 星啊。然后在第二 run 的时候，拿第二份留下来不要动，然后拿第一份3、4、5、6、7、8、9、10去做 training， 然后去测第二份。然后在第三 run 是拿第三份留着。1、2、4、5、6、7、8、9、10去做最佳化，然后测第3份，所以你会测第一份、测第二份、测第三，然后你会测到第10份，总共10 round， 所以最后你还是会有那10，就是10 round 的答案啦啊。所以记得是这样子，好像就是这个样子。